Hello students, welcome to the channel. In today's video, we will do the fourth and the final passage of the reading section of April 2021 ACT Form D05. This is the natural science passage. Passage A is from the article Just Add Water by Jan Zalaziewicz and Mark Williams. Passage B is from the article Plate Tectonics Spotted on Europa by Thomas Sumner. Passage A. A look at our neighbors Mars and Venus shows how lucky Earth has been. They too had surface water in the early days, perhaps even large oceans. On frozen Mars today, we see ancient shorelines more than 3 billion years old and detect clays formed in water. Soon though, Mars lost most of its atmosphere and protective magnetic fields, and its water vapor leaked away. Venus is an inferno surrounded by suffocating clouds of sulfuric acid now, but probe measurements show it too once had abundant liquid water until rising levels of water vapor and carbon dioxide led to a runaway greenhouse effect that boiled it off. So the first paragraph is about the abundant presence of water on Mars and Venus, which are Earth's neighbors in the solar system at one time, and how conditions led to that water disappearing. On Mars, it was because of the poor gravitational pull of the planet that the atmosphere and protective magnetic field disappeared, and with it, the water vapor. And in the case of Venus, it was because of greenhouse effect, right? So Earth is lucky in the sense that in spite of being in the vicinity of these two planets, Earth has not lost its water, and Earth had the conditions that could germinate life. What made Earth different? The key is probably plate tectonics. The movement of segments of Earth's uppermost layer is unique, we think, among the rocky planets of the solar system. They crash against each other, buckling, rising, or driving down into the planet's hot mantle. There is some evidence such tectonics tried to start up on Mars, but if so, it didn't last long. On Earth, it has created natural depressions, ocean basins underlain by dense, newly formed crust that hold deeper waters, and shallow seas on the lighter, more ancient crust of the continents. The bottom of these containers is cracked at the subduction zones where water-soaked plates slide down into the mantle. That water is mostly wrung back out to emerge as volcanic steam and mountain ranges. So the reason Earth has been different from Mars and Venus, and the reason Earth has been able to retain water, the passage suggests is the plate tectonics, right? The movement of the upper crust of the Earth's surface. And this has led to deeper basins, which house the oceans, and shallower basins on the continental shelves, which house the seas, right? This constant cycling of water and the unlikely coexistence of wet and dry surfaces is, it turns out, crucial. Water evaporating from the oceans condenses as rain and chemically attacks the land, modulating atmospheric conditions and global temperature. The atmosphere thus formed has a lid, a cold trap made by the chill of the stratosphere that freezes water vapor out and stops it escaping into space. Below this lid, almost uncannily, all three phases of water, solid, liquid, and gas, coexist almost all of the time. The only planetary surface known where this has been sustained for any long period, right? So we also have something called a cold trap made by the chill of the stratosphere, which provides a sort of a lid to prevent water from escaping into space, right? And below that lid, we have all of this churn going on between the three phases of water. And this is something unique to Earth. To complete this remarkable planetary machine, plate tectonics itself needs water to function. Water lubricates descending tectonic plates and softens mantle minerals so they melt more easily. Geochemist Francis Albarede of the École Normale Supérieure in Lyon, France, thinks that water's arrival from outer space kick-started the plate tectonic motor 3 billion years ago. Okay, so that was the first passage. Questions 31 to 34. So let me just, yeah. Okay, which statement best summarizes the discussion of water in the last paragraph of passage A? So this kind of tells you how plate tectonics also need water to function. Water acts as a lubricating mechanism and how it arrived from outer space to kickstart this process. Water is what makes Earth remarkable among all the planets. After water created natural depressions on Earth, plates could more easily interact with one another. Notable geochemists confirm that water caused tectonic plates and it melts the plates as they descend. Water may have been the impetus for the tectonic process and it helps the plates move more easily. Okay, so it's not A and B because those are discussed in previous paragraphs. I wouldn't say that water caused the tectonic plates. Yeah, it lubricates those plates and softens mantle materials, but it didn't cause the tectonic plates. So I'm a little skeptical of option C. But yeah, it may have been the impetus for the tectonic process and it helps the plates move more easily. So D, I think, is a better answer here. In passage A, the authors mention which of the following is evidence that Mars once had surface water. So it was clay, right? They do say that, yeah, and detect clays formed in water. So Mars has clays formed in water. So that's evidence that it once had surface water. According to passage A, Venus lost its liquid water due to loss of its magnetic field, unchecked infernos on its surface, clouds of sulfuric acid in its atmosphere, rising levels of water vapor and carbon dioxide. So it's D, right? Because if you look at this, it says here that rising levels of, rising levels of water vapor and carbon dioxide led to a runaway greenhouse effect that boiled the water off. So all those other conditions of sulfuric gases, etc., were present, but it was the water boiled off because of the greenhouse effect caused by the rising levels of vapor and carbon dioxide. According to passage A, one main function of a cold trap is to keep water vapor within Earth's atmosphere, chill the stratosphere by freezing water vapor into ice, construct a lid that chemically attacks the land, stop water vapor in space from entering Earth's atmosphere. So it's F, right? You want to keep the water within the Earth's atmosphere, and that is what the cold trap does. It freezes water vapor and stops it from escaping into space. It's given here, right? So, okay, let's now look at the second passage. Plate tectonics churns the icy exterior of Jupiter's moon Europa, researchers reported in 2014. The finding marks the first evidence of plate tectonics beyond Earth. So this passage begins with the discovery of plate tectonics on the surface of Europa, which is Jupiter's moon, and this is the first time it was observed beyond Earth. Earth is not unique. We have found another body in the solar system with plate tectonics, says planetary scientist Simon Catohon of the University of Idaho in Moscow. This tells us that this process can happen on more than just rocky planets like Earth. Previous observations have seen surface reshaping, such as volcanic activity on other planetary bodies, including Saturn's moon Titan. However, Catohon says Europa is the first found with a patchwork of drifting tectonic plates. The rising and sinking ice slabs on Europa's surface may provide a mechanism for nutrients to move from the moon's surface to its subsurface ocean, Catohon argues. Such transport would bolster the likelihood that this ocean hosts life. Astrobiologist Brittany Schmidt of Georgia Tech in Atlanta says the mechanism is very exciting for Europa's chances for supporting life. So Europa is kind of the first which has been observed to have a patchwork of tectonic plates. So it is a kind of more detailed and vaster than what has been observed anywhere else apart from Earth in the solar system. And this could actually lead to a possibility for life in the subsurface ocean on Europa. Though the moon formed over 4 billion years ago, at the same time as the rest of the solar system, Europa's icy surface is surprisingly young. Based on the moon's small number of impact craters, scientists estimate Europa's surface to be just 40 to 90 million years old. Dark bands crisscross the moon where warm, fresh ice wells up to the frigid surface, but a mystery remained. Where is the old material? 2 years ago, Cattenhorn and co-author Louise Proctor of Johns Hopkins University spotted something odd as they scanned a Louisiana-sized portion of Europa mapped by NASA's Galileo spacecraft in 1998. In the moon's northern hemisphere, a 20,000 square kilometer hunk of landscape was missing. Like a torn photograph placed so that the pieces overlap, Europa's crisscrossing surface fractures didn't properly line up. The researchers propose that this discrepancy marks where two massive ice slabs smashed together, with one sinking under the other and blending into the moon's warmer interior ice. The action resembles a subduction zone on Earth where one slab of crust or tectonic plate slides beneath another. So the last three paragraphs kind of look at what the plate tectonics could have done on the surface of Europa. The fact that Europa was formed 4 billion years ago, but the surface seems to be much younger, is a question that needs to be answered, because if the surface is younger, then what happened to the older material that made the surface? And this was answered partly when NASA's Galileo spacecraft brought up images of a 20,000 square kilometer landmass missing from the surface, and that could be due to plate tectonics, the sinking of the surface as happens on a subduction zone on Earth. Okay. In passage B, the author mentions a torn photograph most likely to help illustrate Europa's jagged landscape before plate tectonics emerged there. Clarify that Cattenhorn and Proctor needed to tear the images they were studying in order to replicate Europa's surface fractures. Help portray the fractures on Europa's surface that intrigued Cattenhorn and Proctor. Reveal that the images NASA's Galileo took of Europa's surface fractures were somewhat flawed. So it's clearly not B and D, because that metaphor is here. Like a torn photograph placed so that the pieces overlap, Europa's crisscrossing surface fractures didn't properly line up. Right? So there was something about the picture which indicated that these were not lining up properly. These surface fractures had happened and they were not lining up properly. So it's not about the jagged landscape before plate tectonics emerged there, right? It's not about that, because those fractures were the result of plate tectonics. It helps portray the fractures on Europa's surface that intrigued Cattenhorn and Proctor, and which they said was the result of plate tectonics. According to passage B, scientists base their belief that Europa's surface is relatively young on its subsurface ocean, small number of impact craters, patchwork of drifting tectonic plates, dark crisscrossing bands, and ice surface. So this comes here, right? Dark bands crisscross the moon where warm, fresh ice wells up on to the frigid surface, right? So because fresh ice wells up and creates these bands, you know that the surface is much younger. As used in line 80, the word scarred most nearly means. So they spotted something odd as they scarred a Louisiana-sized portion of Europa mapped by NASA's Galileo spacecraft. So as they scarred, as they looked at, as they examined, right? That is what they noted. So as they thoroughly examined, right? It's not about cleaning. They are looking at an image from Galileo. It's not about searching within a stack, which is what rummaging means. To rummage is to search within a pile. And it's not about dredging, right? You're not trying to bring material out of the ground or bring something from the past back to the present. So it's about examining. Okay, 38, based on the passages, Earth can be considered unique because it is the only known body in the solar system with tectonic plates that drift across its uppermost layers. where tectonic plates can transport nutrients below its surface, where water, ice, and water vapor share a sustained coexistence that had surface water 3 billion years ago. So I think it's obviously between F and G, because both passages, the first passage very clearly talks about tectonic plates' uniqueness to Earth. But the second passage says that, yeah, there is another body in the solar system with plate tectonics. Previous observations have seen surface reshaping, so that's definitely not it. Yeah, so it's not F. Tectonic plates can transport. No, it's not G also, because we know that in Europa it happens. So obviously it has to be between H and J. Where water, ice, and water vapor share a sustained coexistence. Yeah, it is H then. Yeah, because we know that here in the case of Europa, we know that there is no vapor. We know that there is ice and there is a subsurface ocean, but there's no vapor. So the fact that all three are present is something unique to Earth. And the first passage obviously says that this happens only on Earth. Okay, so this was a good question, right? Because the tectonic plates is something which the first passage says is unique to Earth, but not the second one. The functions of the first paragraph of passage A and the third paragraph of passage B are similar in that both paragraphs. So first of A, which compares Earth to the neighbors, and the third of this, which compares, which again compares kind of plate tectonics on other planetary bodies. They are similar in that they use other planetary bodies to highlight the uniqueness of Earth or Europa, introduce the discovery of plate tectonics on Earth or Europa, contrast previous discoveries of volcanic activity with newer discoveries of tectonic plates, explain how various planetary bodies lost their surface water. Right, so it is A, right? Because in the first, you obviously compare Earth with Mars and Venus to say, this is why Earth is unique, because it has water, right? So it doesn't really talk about tectonics yet in the first paragraph. It's only about the presence of water. And the third paragraph of the second passage says that Europa is unique because it has tectonics, which, for example, Saturn's moon does not have. So it is about highlighting the uniqueness of Earth or Europa. In Earth's case, the presence of water. In Europa's case, the presence of plate tectonics, right? So the plate tectonics bit is not presented in the first paragraph of passage A. It can reasonably be inferred from both passages that tectonic plates most greatly influence a planetary body's ability to support life. When tectonic plates buckle during impact with volcanic plates, if the tectonic plates consist of ice rather than rock, when one tectonic plate slides beneath another, if the tectonic plates are less than 90 million years old. So it is H, right? Because we know that when one tectonic plate slides beneath another, it creates a subduction zone, right? And that subduction zone is responsible for the creation of life. Because, because it says here on Earth, this has created natural depressions that hold deeper waters. The bottom of these, this constant cycling of water and the unlikely water evaporating. Yeah, so this is responsible for the coexistence of vapor and gas, vapor and solid and liquid water, right? Which has led to the emergence of life. And in the case of Europa, the fact that the two massive ice slabs slashed together with wind sinking under the other and blending into the moon's warmer interior ice. This subduction process, which is similar to what happens on Earth, led to life, right? It's not about ice versus rock. Yeah, so it is definitely H, because that sliding action leads to the presence of would lead to the presence of a subsurface ocean which can host life. So it is Yeah, H. Okay, so let's grade this. This is reading 31 to 40, DGDFC, DGDFC, 36, GDHAH. Okay, 36 is G, okay. Okay, 36 is GDHAH. Okay, so 36 we got wrong. According to the passage, scientists base their belief that Europa's surface is relatively young on its. So isn't okay. So though the moon formed over 4 billion years ago, Europa's icy surface is young based on the moon's small number of impact craters. Okay, so the basis of the estimation of the age, uh, the basis of the estimation of the young age is on the small number of impact craters. And that is further proved by these crisscrossing bands, right? Yeah, I think the icy surface was probably something that could be avoided in this because the dark crisscrossing bands indicate that there is fresh ice that rises to the surface. And that indicates that the surface is constantly churning, right? Yeah, but so even if we keep that, I think the relative young age comes from the small number of impact craters, right? So yeah, so this was a good question. I think the idea that you're looking at the young age from the small number of impact craters is then further explained with the how the surface looks. Okay, so that was the last passage. And with this, we finish the solution series for Form D05. I've uploaded the videos for all sections now, and I'll link to them in the description box. So make sure you check them out. Hope this was useful. If it was, hit like and subscribe to the channel. Let me know what other videos you'd like me to upload. I'll see you guys in another video soon. Take care. Bye-bye.